Good morning to everyone. My name is Zvonimir. I am a PhD student at the Faculty of Electrical Engineering, Computer Science and Information Technology, Osijek. Today I will present you this short presentation, paper Optimal Load Management of Prosumer with a free power plant and battery storage. I will start with short motivation. We have increase in electricity price this year. There are two main reasons for that. First reason is the increase in price of natural gas. In European Union is still around 20 to 25% of electricity generation from gas power plants, and this year was very dry, so generation from hydropower plants is reduced. Idea to reduce electricity cost is to reduce our consumption, but without ruining our life comfort. So what we can do is to replace all the household appliances with renewable efficient appliances, and also to replace all incandescent light bulbs with new and efficient LED lights. To reduce electricity cost even more, we can do load shifting. The idea is to move consumption from period of high electricity price to period with a low electricity price, and this is the reason why we all have two rate electricity meter at our homes. But we can't shift any type of load in our home. We have shiftable loads and non-shiftable loads. Shiftable loads, for example, washing machine, dishwasher, tumble dryer can be shifted in any time, can be used at any time of the day. And the non-shiftable loads, for example, ovens, fridge, lighting, is to be used when we require them. For example, we need fridge all time to preserve food, or we use oven when we are hungry and want to prepare something to eat. If we add a power plant on our house, idea is to move consumption from period of high price to period when we have more generation from power plant. And if we add battery storage, then there is no need for moving consumption, because battery can be charged when we have excess generation from power plant. And then this stored energy can be used to cover consumption when price is high in the afternoon and evening. Methodology in this work is applied on a Prosumer in Croatia with power plant and battery storage. It is single phase producer, so rated power of power plant is limited to 3.68 kilowatts, which is also the rated power of battery storage, and rated capacity is 10 kilowatt hours. To decide when to charge and discharge battery, and to decide when to turn on shiftable devices, we need optimization. Optimization in this work is mixed integer programming. Objective function is minimization of electricity costs. Code is done in Python, and the solver which is used is Gurobi optimizer. Input data which is required is a generation from power plant, which is measured for 1 month with 10 minutes time step, and a load amount of non-shiftable load, which is measured for 1 week, and assumption is that it is same every week during month. We also have load profiles of 5 shiftable loads which are measured, and we consider electricity prices which are current actual in Croatia from April this year. We have 3 scenarios. Power plant is installed in all three scenarios. In scenario 1, time of using shiftable loads is fixed and time is presented in table. In scenario 2, we applied optimal load time shifting, and in scenario 3, we add battery storage. Results will be presented for 2 different days, for one sunny day and for one cloudy day. Here we can see the results for scenario 1. I say that time of shiftable load use is fixed, so it's not depend on generation from power plant. And monthly electricity bill for this scenario is 46.63 euros. In scenario 2, we can see for upper figure for sunny day, loads are shifted when we have generation from power plant, and for down figure for cloudy day, it's more profitable to use loads when electricity price is low. And this small amount of generation is better to use to cover fixed load demand. Now electricity bills reduced to 5.1%. In scenario 3, it is more profitable to use devices when electricity price is low. Only air conditioners are used when price is high because we need them over there when it is hot. Electricity bill is now reduced for 26.8%. Here we can see battery charging and discharging on the left and battery state of charge on the right. The first figure is when it is sunny day, battery is charged from grid and electricity price is low, and from excess of generation from PV power plant, and then this stored energy is used to cover low demand in the afternoon and evening when still electricity price is high up to 22 hours. When it is cloudy day, battery is charged only when electricity price is low, and this stored energy is used overday to cover low demand. On the right, we can see battery state of charge. It is limited between 20 and 80%, and it is 50% at the start of the day and at the end of the day. Here, on the left is comparison of received and delivered electricity in all three scenarios. We can see that more electricity is received than delivered, and on the right, we can see comparison of electricity which is received at high price and at low price. More is received at low price, and biggest difference is in scenario 3, where only 33 kilowatt hours is received at high price and 315 is received at low price. It is because battery is charged when price is low, and then used to cover consumption when price is high. It's around 9 to 10 times more low price. In conclusion, we apply this methodology to a prosumer in Croatia with our prices, so results can be slightly different for other countries because different prices of electricity. Limitation of this method is one assumption that we use every distributable loads once every day, which is not always correct. For example, we can use washing machine today 3 times and next 2 days we don't use it. Plan for future work is to apply the post method to whole year to see difference between the summer and winter season, and also to consider temperature data for decision on using of air conditioner. It's also possible to consider different cycles of washing machine, for example, short or long cycle, or on low temperature or high temperature, according to different types of clothes. And also, charging stations for electric vehicles can be considered as one of shiftable loads in future. This work was funded by European Union.
Any questions?
Yes.
So this case for integration is mostly taking as an example for inlands, or it can also be applied for the case of islands, like Portugal or something like that, because the photovoltaic effect in inlands or in the insular will be slightly different.
Yes, it is applied for Osijek, for Croatia, northern part, and if it will be applied on southern Croatian island, there is more generation from France pipeline, so results can be different, but it's not considered, it's not studied in this case.
Because the prices are
Prices
not
are
the same.
same.
Are the same,
Yeah.
both in island and inland. Wow.
But more generation can be, more electricity can be produced, so maybe slightly different results, but not very big difference.
Okay, thank you.
Okay. Yes.
Just a clarification regarding the prices. The tariffs is time of use tariffs, and you have.
It is two tariff one during the day from 8 in the morning to 10 after in the evening, and low tariff is from 22 to 8 hours.
And in the load shifting profiles, you have kind of fixed cycles for the appliances.
One cycle every day.
Yes, but I mean, in terms of the cycles of operation, you distinguish, or you just see a certain load for 1 hour duration, let's say?
is a load profile for duration for load. I can show you. Loads have different configuration. But it can be seen here. But we measure the load profile for every type of load.
Okay.
With 10 minutes time step. So we don't have one power for our tool, but we have real profile of load.
Okay, thank you very much again.